If AI is going to run delivery networks, factory systems, traffic tools, or public services, one problem matters right away. What happens when the world changes before the machine finishes its plan? That is why this new tutorial matters now. It does not present AI as a system that thinks once and then acts blindly. Instead, it shows an agent working in a changing environment, updating as it goes. The example is simple: a grid world with moving obstacles and a shifting goal. But the underlying question is bigger and very relevant to China. China is investing heavily in AI for real-world deployment, not just chat interfaces. In that setting, reliability under changing conditions becomes central. The value here is not drama, it is clarity. The tutorial gives a concrete example of how an AI system can act, watch, reconsider, and adapt while the task is still underway. The source is a hands-on tutorial from Mark Tip Post. It builds what it calls a streaming decision agent. The agent thinks on DAX online in a dynamic environment. It also streams partial reasoning updates in a structured form. That matters because the system is not only making choices, it is also exposing those choices in a safer, more inspectable way. According to the article, the tutorial defines a streaming event schema and core type structures, using PYD antic to keep outputs formal and consistent. It then creates the changing grid world, with moving obstacles and a moving target, to test planning under uncertainty. The planning method is online A in a receding horizon loop. In plain terms, the agent only commits to a few near-term moves, then checks again. If conditions change, it replans. If a specific step becomes unsafe or invalid, a local risk check can override the old plan during execution. This approach matters because static planning often breaks in live settings. A route that looks efficient 1 second can become wrong the next. A target can move. An obstacle can appear. A safe step can become risky. The tutorial's answer is not to solve everything in advance. It is to keep planning alive during execution. That is the significance of online planning and reactive mid-execution adaptation. The agent monitors conditions continuously and can override its own earlier decision when needed. The article also stresses a computational budget. That point is easy to miss, but it is important. In real systems, you cannot always afford endless deliberation. So the design balances action with limited planning time. It's a workable next step, not perfect foresight. For anyone watching China's AI push, this is a useful lens. The challenge is often not raw intelligence. It is whether a system stays usable when reality becomes messy. So, where does China fit in if the article itself is a general AI tutorial? The connection is about application and scale. China's technology strategy has long emphasized deployment in logistics, manufacturing, mobility, and urban systems. Those are exactly the kinds of environments where conditions shift constantly. In that context, the tutorial reflects a broader design problem that China will face along with everyone else: how to make AI systems observable, controllable, and robust while they are already acting in the world. The source does not claim this tutorial came from a Chinese lab, and we should not overstate that. But for a channel about China's big questions, it is still relevant because it sharpens the real issue. The next phase of AI competition may depend less on who has the flashiest model and more on who can build agents that handle changing conditions safely, within constraints, and with clear records of what they are doing step by step. It is worth being precise about the limits. This tutorial demonstrates a concept in a dynamic grid world, not a full production system. The article says the agent can stream structured reasoning updates, replan as obstacles move, and complete a task under changing conditions. That shows a practical architecture for incremental reasoning and execution. It does not prove that such agents are ready for every high-stakes deployment. Still, it gives viewers a clean way to understand an important technical shift. The question is moving from can an AI produce a plan to can an AI keep making sensible decisions while events keep changing. That is a more grounded standard, and it is especially relevant in countries like China, where digital systems are often discussed in terms of large-scale coordination and real-world operations. The takeaway is simple. Adaptive AI is becoming less about sounding intelligent and more about staying reliable when the map no longer matches the road.